Alright guys, welcome to my video on the composition of functions 2, video 2. And on this one will be more of I say a challenge, a little bit more work, but it's definitely achievable. So we have two functions. We have k of x equals to x divided by x minus 2, and m of x, which equals to 6 divided by x squared minus 1. We want to find k of m of x and the domain. So I'm going to take my time doing this one, but please pay attention to this one because this one may be on an exam. Maybe not as hard, but something like it. So k of m of x, which equals to k of m of x. Now remember, there's no value for x in this case, so I can't evaluate anything. But what I can do is, I know, based on this, that m of x equals to 6 divided by x squared minus 1. So I can replace m of x here with 6 divided by x squared minus 1 into my k function. So instead of having k of m of x, I have k of 6 divided by x squared minus 1. Now, I must plug this value, inside of my k of x function k. So in this case, wherever I see an x in function k, I'm going to leave an open parenthesis. And inside of my open parentheses, I'm going to substitute 6 divided by x squared minus 1 into my function. So now on top, I have 6 over x squared minus 1 divided by 6 divided by x squared minus 1 minus 2. This is a complex fraction. I got to simplify this. I can't leave it looking like this. So what I'm going to do is, I first want to focus on my denominator, but I'm going to write it over here. Now I'm going to write 2 as a fraction. 2 over 1. And when I subtract fractions, they must have the same denominator. Let me write it a little bit better, by the way. 6 over x squared minus 1 minus 2 over 1. They must have the same denominators. So the LCD for my denominator is going to be x squared minus 1. Now my first fraction has an x squared minus 1, but the second one doesn't, which means I'm going to multiply x squared minus 1 to the denominator of my second fraction, and whatever I do to the bottom, I must do to the top, x squared minus 1. So now I have 6 divided by x squared minus 1, which will now be divided by 6 minus 2 times x squared minus 1, divided by x squared minus 1. Because same denominators now, I can now subtract the tops. I'm going to perform something that you probably remember, which is called keep, change, flip. Because I'm dividing one fraction by another fraction, which means I can keep the top fraction the same, change the overall division to multiplication, and flip the second fraction. So now when I do that, I have 6 over x squared minus 1 times x squared minus 1 divided by 6 minus 2 times x squared minus 1. Before I simplify, before I simplify my fraction even further, I just want to distribute inside the parentheses here. And that's going to be 6 over x squared minus 1 times x squared minus 1 divided by 6 minus 2x squared plus 2. Because negative 2 times x squared is negative 2x squared. Negative 2 times negative 1 is positive 2. If you notice, I have two fractions. So when I want to find my domain, I'm going to do it over here. When I want to find my domain, I must take each fraction, each denominator, which is going to be, when I simplify a little bit further, x minus 1 divided by, combine like terms, that's going to be 8 minus 2x squared. I want to take x squared minus 1, set it not equal to 0, and solve for x. And I also want to take my other denominator, which is going to be 8 minus 2x squared, set it not equal to 0, and solve for x. Because I have two fractions, therefore I must set both denominators not equal to 0 and solve for x to find the domain of my function. Anyways, let's continue simplifying now. Although these are two different fractions, but there's an operation going on between those, which is multiplication. So I can do cross simplification by simplifying my x squared minus 1s, leaving a 1 here and a 1 here. And when I do that, on top, I'm just left with 6, and my denominator, I'm left with 8 minus 2x squared. We're not done. We got to still simplify. What I'm going to do is here, I'm going to factor out a 2 out of my denominator. Because when I factor out 2 out of my denominator, I can simplify 6 into 2. The 6 on the top and the 2 on the bottom. Because the greatest common factor is going to be 2. When I factor out 2 out of my denominator, I'm left with 4 minus x squared inside my parentheses. And 6 divided by 2, when I do that, it's going to give me 3 on top and 1 on the bottom. So that's going to be 3 divided by 4 minus x squared. And that is my simplified fraction. So a lot of work, yes, to find k of m of x. But we're still not done, because now we must find the domain. And remember, although we have one complete fraction now, but I must consider the denominators for all of my fractions. So now I want to find my domain. So x squared minus 1 cannot equal to 0. And the other one is 8 minus 2x squared cannot be equal to 0. Let's solve for x in each of those. Let's add 1 here. So x squared cannot be equal to positive 1. We want to solve for x, so you must get rid of the square by taking the square root of both sides. There's an invisible 2 as the index. Simplify each other out. I'm left with x cannot equal to. Remember, when you apply the square root to solutions, plus or minus, the square root of 1 is just going to be 1. The same thing when you do for the other one. I'm going to subtract 8 from both sides. When I do that, I have negative 2x squared cannot be equal to negative 8. After that, divide negative 2 from both sides. X squared cannot be equal to positive 4. And to get x by itself, I'm going to apply the square root to both sides. Once again, remember, two solutions. The power and root simplify each other out. So x cannot equal to plus or minus. The square root of 4 is going to be 2. And remember, this is all for our domain. We already found k of m of x in simplified form. Then we're going to find the domain of that. So now we're going to place all our critical values on our number line. Starting from the smallest to the largest. So we have negative 2, because it's plus or minus 2. Then we have negative 1, from the plus or minus 1. Then we have positive 1. And then we have positive 2. If I need to break it up, this is negative 1, this is positive 1, this is negative 2, this is positive 2. All those are going to get open circles because it cannot be equal to. And there's 5 parts to the domain. A part that goes from negative infinity to negative 2. A part that goes from negative 2 to negative 1. From negative 1 to positive 1. From positive 1 to positive 2. And from positive 2 to infinity. All right, guys, that is it to this question. I know it was a lot, but I took my time breaking this down. If you do it yourself, it should take you no more than maybe 5 minutes, I say. But take it as long as you need to. Hopefully you like how this looks to you. It's pretty straightforward. And I'll see you soon. Take care.